In this video, the learner will set up trigonometric ratios of a triangle to reflect the relationships of the sides to the angles. The word trigonometry comes from two Greek roots, trigon meaning triangle and metron meaning measure. So the word literally means measure of triangles. A trigonometric ratio is a ratio of the sides of a right triangle. So we can compare two sides of triangle ABC. So an example of a trig ratio for this triangle would be AB to BC. Or we could compare AC to BC, or even AC to AB. Now, consider these two triangles, ABC and DEF. They're both right triangles. We have angles B and E that are congruent to one another, but triangle DEF is not congruent to triangle ABC. They have two sets of angles that are congruent, therefore those triangles are similar. So if we have two right triangles and we know a set of the acute angles are congruent, we know those triangles are similar. Any set of right triangles with a known acute angle will be similar to another with that same given acute angle. So therefore, the trig ratios for those triangles will always be the same because those sides are then proportional because the triangles are similar. Now, it's important to note, this does not mean that the sides are congruent, only that they are proportional. That the ratios are what will be equal. So AB over BC will be congruent to DE over EF, for example. Now, there are trig ratios that we were going to be dealing with in geometry. These are called sine, cosine, and tangent. And here are the definitions of each one of those. In a triangle ABC, that is a right triangle, with the acute angle A, the sine of that is the ratio of the length of the leg opposite to the length of the hypotenuse. In a right triangle for acute angle A, the cosine of angle A is the ratio of the adjacent leg to the length of the hypotenuse. And in triangle ABC, with an acute angle A, the tangent will be the ratio of the opposite leg to the adjacent leg. We're going to use this diagram to illustrate the definitions of sine, cosine, and tangent. When looking at sine, cosine, and tangent, you always want to identify your angle first. Our angle in this picture is represented by theta. Theta is the angle that we're going to be talking about. From theta, from your angle, you have to identify your opposite side. So from theta across the triangle, our opposite side is represented by y. From theta, the adjacent leg of the triangle is x. So from this angle, the opposite side is y, the adjacent side is x. Based on the definition of sine of an angle, that is represented by the opposite side over the length of the hypotenuse. So here, that would be y and r. So the ratio for sine would be y over r. For cosine of theta, the definition says that is adjacent over hypotenuse. So the cosine of theta would be x over r. Tangent of theta will be the opposite leg over the adjacent leg. So y over x. Now we're going to take a look at a numeric example. We want to express each ratio as a fraction. So we're going to come up with sine, cosine, and tangent of each acute angle in this right triangle. So if we want the sine of P, that means the sine of angle P. So first I have to identify what the opposite sides are and adjacent legs are so that I can find the trig ratios. Across from P is going to be the 15. The adjacent leg to P will be 8. So that's going to help me set up these trig ratios. So sine of P is opposite over hypotenuse. So the opposite is 15, the hypotenuse is 17. So 15 over 17 is the sine of angle P. Cosine of P is adjacent over hypotenuse. The adjacent leg is 8, and the hypotenuse is 17. The tangent of P is the opposite leg over the adjacent leg. That's 15 over 8. Now for sine, cosine, and tangent of Q, I need to identify from Q what the opposite side will be and the adjacent leg. The opposite side from Q is 8. The adjacent side to angle Q is 15. Now, the 17 is also an adjacent side to angle Q. However, when we look at adjacent, we mean the adjacent leg of the right triangle. Now, to look at sine of Q, sine is opposite over hypotenuse. Opposite from angle Q will be 8. The hypotenuse is still 17. So 8 over 17 is sine of Q. Cosine of Q is adjacent over hypotenuse. The adjacent leg is 15. The hypotenuse is 17. Tangent of Q will be opposite over adjacent. Opposite from Q is 8. Adjacent to Q is 15. So 8 over 15 is the tangent of angle Q. Okay. I want you guys to try this example. You're going to find sine, cosine, and tangent of angle J and sine, cosine, and tangent of angle K. An acronym that you can use to remember sine, cosine, and tangent is SOH-CAH-TOA. Sine opposite hypotenuse is SO. Cosine adjacent and hypotenuse is CA. Tangent opposite and adjacent is TOA. And those just come from the definitions of sine, cosine, and tangent. They're based on those definition equations that we saw in our diagram.